So this is the third topic under counting techniques, the combinations. The difference between permutation and combination is, in permutation, we consider the order, right? There is the ranking, who comes first, which is the second, which is the third, and so on. Right? So the way you select, the order matters. But in combinations, you simply select R objects out of N objects without regarding the order. So regardless of the order, how many ways that you can choose R objects out of N. So that is the combination. In permutation, we did the same, selecting R objects out of N, but in order, right? So the order mattered in permutation, but in combination, you simply select R objects out of N, okay? Since the order is not going to consider the number of ways or the possibilities that you can count under combination will be less than the permutations, right? And you don't care about the order, who comes first, second, or third. If you have three objects, then order does not matter. It's just one selection, right? When order matters, there will be 3 factorial, 6, right? But when it comes to combination, all 6 will be considered as just 1, okay? So therefore, combinations, the number of possible ways of selecting R out of N without the order, it's going to be less than the permutations, okay? So let's try to understand this. So you see different marbles in a sack, right? How many are there? There are 12 marbles, right? So out of these 12 marbles, how many possibilities are there to choose 5 out of them, right? Selecting 5 marbles out of 12. Now you do not care when you select these 5, whether red comes first, the blue comes next. Likewise, you don't care. Somehow there will be just 5 marbles, okay? Now think about this example. Let's try to figure out or extend the idea of permutation into combinations, okay? Right. So in this example, you have to find how many distinct ways, that means how many different ways that a person can gather data for a market research. You have to select 3 out of 20 households living in a certain apartment complex, right? So there are 20 apartments. Out of them, you have to select only 3, right? There are 20 households in the, let's say 20 houses in the complex. You have to select 3 out of these 20, okay? Now suppose these 20 houses, you have the numbers. These are their numbers, right? Okay, so these are the households numbers in order. So you have to select 3 out of 20. Suppose you select the first 3. If you consider the order, what will happen? You can choose 1 first, 2 second, 3rd. Or you can choose it like this. Or you can choose like this. Or you can choose like this. So how many different ways? There are 6 different ways if you consider the order, right? If you consider the order. So how do you find that? By permutation, right? That is 20 permutation 3. So there will be 6,840 ways of selecting 3 households out of 20 if you consider the order, right? That means each and every time you select 3, you have this order. But when you do not have to consider the order, these 6, right, will be considered as just 1. All these 6 will be considered as just 1 selection. Why? Selecting just 3 households, 1, 2, and 3 out of this 20. You don't care whether 1 comes first or the second household comes first or the 3rd comes first. You don't do that, right? So therefore, all these 6 orders, right, doesn't matter. This is just going to be just 1 selection, selecting the first 3 households out of the 20. So what should we do? That will happen for each and every permutation you take. There will be the same thing will be counted 6 times. So you have to get rid of that. So which means you have to divide the permutation 20p3 by 3 factorial. So what will happen? You have 20p3, you divide it by 3 factorial. That means 6. So 6,840 have to divide it by 6. So that will avoid the repetition of orders. Therefore, the number of possibilities that you can select 3 out of 20 without order, it's going to be only 1,140. Is that clear to all of you? Why we divide by 3 factorial or 6? Because we are not going to consider the order. So all these 6 ways, it will be considered as just one selection. Just selecting 3 out of 20. Right? So for all these 6,840, there will be the same thing has been counted 6 times or 3 factorial times. So you have to get rid of them. So you divide the 20 permutation 3 by 3 factorial. So that will be the combinations, right? So what is the notation for combination? NCR, C for combination. So what should we do? We find the NPR, then it divides by R factorial, right? So as a theorem, here's the number of combinations of n distinct objects taken R at a time, NCR, or you use the other notation, NR within parentheses. That will be n factorial over n minus R factorial, that is the NPR, and then additionally, there will be another R factorial division. So this is the calculation for NCR. Okay? Right. So again, in your scientific calculators, you can find NCR, maybe the button or under a subselection, right? Or you can very easily calculate this by hand when they are smaller numbers, right? Okay, let's try an example. In how many different ways can 6 tosses of a win yield 2 heads? What does that mean? Right? So this is a coin toss, okay? You toss a coin, it has head or tail, right? So let's say getting head is the win, right? So simply, how many different ways that you can get 2 heads if you toss a coin 6 times? So how do you find it? 6 choose 2, right? So you may end up with how? 2 heads. Right? So likewise, you can end up with different possibilities that you can get 2 heads, and the others will be the tails, right? So that will be 6 choose 2, and you are not considering the order, right? You are not considering the order, so it's 6 choose 2, so it will end up with 15, right? So if you do the hand calculation, you can expand 6 factorial up to 4 factorial because that is the largest value on the denominator. So this 4 factorial you can cancel out. 2 factorial is 2, 2, 3, 3 times 5, 15. Okay. Right. Let's try another example. Try this one. Suppose there is a group of 7, say, members of a society, right? So there are 7 members, a group of 7 members. You want to select a committee of 5. You want to select a committee of 5. Now, these type of questions, I'm sure you have done in your advanced level also, right? So how many different committees can be formed? So how do you find it? You have to choose 5 out of 7. Okay, just a committee. So no ranking, no president, secretary, nothing. Just a committee of 5 out of 7. Yes. Find the value and share it with me. So this is going to be NCR, right? What is N? What is R? You have to do 7, choose 5, right? 7, choose 5. It will be 7 factorial, 5 factorial, 7 minus 5, 2. Now you should be able to see the pattern here. So at the top you have 7 and at the bottom you have 5 and 2. 5 plus 2 is 7, right? Now always you have, when you add the value at the bottom, they should add up to the numerator. So 5 plus 2, 7, right? The answer will be 21. Okay. Now I want to add a small restriction, right? Suppose there are 4 males and 3 females in this group. Right? So there are 7 members. So the 7 members, it's formed as 4 males and 3 females. Okay. Now your committee should be, let's say, if the committee has to be made with 3 males and 2 females. So that will add up to the 5, right? So your committee of 5 should be 3 males and 2 females. If so, how many committees are possible? Can you find this one? Now your 7 members, it's 4 males, 3 females. So from them, you have to select the committee of 5. That committee should contain 3 males and 2 females. How do you tackle this question? Right. So here's my 7-member set, right? How many males are there? 4 males, 3 females. Okay. So what is the formation of the committee? There should be 3 males and 2 females. So you have to select these 3 males out of these 4 females. So you have to select 3 males out of these 4 males, and you have to select 2 females out of these 3 females. So how do you select the committee? Yes, I got one answer correct. Ilham, you are correct. Yeah, Niroshika, you're also right. Yeah. So how do you do that? So the number of possibilities to select males is 4, choose 3. You can select 3 males out of 4, and then you can select 2 females out of 3. So that will be 4 choose 3 will be this. 3 choose 2 will be this, right? So this is going to be just 4. This is going to be 3. Do you add or multiply? That's the first theorem, right? Have to multiply. So the number of possible committees will be 12. Okay. So this is how you choose a committee of 5 with 3 males and 2 females out of 4 males and 3 females. Right. Any questions so far? Right? Okay. Here's the next restriction. You want to select a committee of 5 where there is at least one female. At least one female should be there. If so, how many possible committees are there? So your committee should have at least one female. How do you do this one? Right. So let's first see how you can form these committees. Okay. Males, females. I'm going to write down the number, right? So you can form a committee, at least one. If you have one female, the rest should be males. Can you have 4 males? Yes, there are 4 males, so you can do this, right? One female, 4 males. At least one, so you may go with 2 females. If then, there will be only 3 males. We can have 3 females, then there should be only 2 males. Or you can go for 4 females. Can you do that? Can you go for 4 females? Do you have 4 females? No, you have only 3. So this is not possible. So these are the 3 possible ways that you can form the committee. At least one female. That is 1 female, 4 males, 2 females, 3 males, 3 females, 2 males. Now you have to figure out how many possible ways that you can create a committee with 1 female, 4 male. So this will be 4 choose 4 times 3 choose 1. Right? Next one, 4 choose 3 times 3 choose 2 that we already found. The other possibility, 4 choose 2 times 3 choose 3. Right? So this is going to be 4 choose 4 is 1, right? The ways to select 4 out of 4, that's 1 way. It's 3 ways, so this is 3. This is 4 times 3, 12. 4 choose 2 is 6. 1. Now this you have to add, right? These are possible ways. So, I mean, different committees. So these 3 values you have to add. So there will be 21 different committees. Okay. So this is how you find when you have restrictions like this. Okay, is it clear to all of you? All 3 parts of this question? Right? Okay, let's try another one, a very similar one. See whether you can answer this one. It's the second exercise. Suppose you have a box. This box contains a box of marbles. Let's say 9 marbles. Okay, a box containing 9 marbles. There are 2 white marbles, 3 blue marbles, and 4 red marbles. Okay. How many different ways? Are there to select 3 marbles? Now, no restriction there, right? Just selecting 3 marbles out of the 9. What is the answer? Until you find the answer, I'll give you the second one. Okay, so the answer for the first one, let's see, 84, yeah, that's correct. 9, choose 3. That will be 84. Now, I assume that you do these calculations by yourself, not just sitting and idling and looking at the screen. Use your pens, pencils, with your notebooks and do these calculations with me, okay? What about the second one? Okay, I'm getting the answers. Try. Others also try. I always see few students answering the question. Right, so what is the answer for the second one? That means all 3 marbles should be different in colors, right? 1 white, 1 black, not blue, black, 1 red, right? So how do you do that? Selecting 1 white out of 2. 2, choose 1. Selecting 1 black out of 3. 3, choose 1. Selecting 1 out of 4 reds. 4, choose 1. So I will get 2 times 3 times 4, which is 24. Right, so I've got the answer. Right, now try the next one. It's similar to the previous one. Selecting 3 marbles with at least 1 black. How do you try it? So you have the black and the others, right? So you don't care what will happen to the others, right? The only thing restriction is you have to have at least one black. Others can be any, right? So the first one, you can have one black and the other two, right? It can be any color, right? You don't care. At least one black. So you can have two blacks, one from other colors. So you can have three blacks. So there won't be any other color, right? The reason is there are three blacks, so you can go for up to maximum three black colors, right? Okay. So what is the possibility? Selecting one out of three blacks. So other two out of how many? How many remaining marbles are there? Three blacks and the others are two and red, four, two whites and four reds. That means there are six, right? So out of six, you have to choose two. Right? You don't care whether red or white, just out of six, right? Six, selecting two. And if you have to select two black balls out of the other six, you have to select one. And the last one, you have to choose three black balls. There's nothing from the rest, right? Okay, so what do you get? 3 choose 1 is 3, 6 choose 2 is 15, which is 45. The other possibility, 3 choose 2 is again 3, right? 6 choose 1 is 6, which is 18. 3 choose 3 is just 1, and this is also 1. Why? By definition, 0 factorial is 1. This is 1, why you get 1. Same for 6 choose 0. Add them together. So there will be 64 possibilities. Okay. I guess it's clear to all of you now, right? So we did the different examples. Now you can even change this to at most, right? You can have at most 3 reds or 2 reds at most. What does that mean? The maximum you can have is 2, or it can be less than that, right? Most. At most 2. So you cannot go for 3 reds or 4 reds, right? So that is also possible. The same thing, just figure out how many will be from the rest so that the total is 3 marbles, right? Okay. So let's move on to another example. Try this one. How many different committees of 2 chemists and 1 physicist can be performed from the 4 chemists and 3 physicists on the faculty of the same college? So very similar to the forming the committee. Instead of males, females, now you have chemists and physicists. See? Yeah. Right. So you can select 2 chemists out of 4. So 4 choose 2. And 1 physicist from 3. 3 choose 1 and then you multiply 6 times 3, 18. Okay. Now let's try when you have the repetition. So the set partitions. Okay. This is very similar to the repetitions that we had in permutation. So suppose you have R objects selected from n distinct objects, right? That is selecting R out of n choose R. Now the restriction is, or the condition is, this is a combination of R objects selected from these n different objects may be considered partition of n objects into two subsets containing respectively R objects and n minus R objects, right? So that is the easiest way to think about. When you select R objects out of n, it will automatically divide the total n objects into two. That is set of R and the set of the rest, that is n minus R, right? So which means you have n objects, then you select R, the rest n minus R, right? So altogether you have R. So it is like you are partitioning your total number of objects into two. When you select R objects out of n, you actually partition your total objects into two. One part with R objects, other part with n minus R objects. If you take this into general setup, you can partition the set of n objects into k subsets, right? Which requires that each of the n objects must belong to one and only one of the subjects, which means mutually exclusive, right? So your n objects, they will be partitioned into many, let's say k, and the objects will belong to one of these partitions. One and only one object cannot be in two, right? Likewise. So an object must belong to one and only one of the subjects. So there will be, in this case, I have 1, 2, 3, 4, 5, 6. N is divided into 6 subsets or 6 partitions, and these n objects are distributed among these n subsets. Right? Say, for example, you have the letters A, B, C, and D, n equals 4. You can partition this into two, one part containing two, other containing another two. So you may partition it in different ways. One way is AB in one part, CD in the other part, or AC in one part, BD in the other, AD in one, BC other. Now, likewise, you can partition 2 and 2 in different ways. So we can figure out actually how many different partitions that we can do, right? How many different partitions that you can do 4 letters into 2 partitions, 2 containing each. So how do you find that? Here's the theorem. The number of ways in which a set of n distinct objects can be partitions into k subsets, right? N1 objects in the first subset, N2 in the second, and likewise Nk in the kth subset. Then the number of ways will be n factorial divided by n1 factorial, n2 factorial, all the way up to nk. And this n1 plus n2 to nk, they should add up to the total n. That is the partitioning, right? So the sum of the values at the bottom should add up to the total n, right? So this is very similar to the repeated permutations, right? So here's an example. How many different ways can a set of 4 objects are partitioned into 3 subsets containing respectively 2, 1, and 1 on each? So what does that mean? You have 4 objects, you partition it into 3 subsets, right? So n is 4, partitioned into 3 subsets, k is 3. So like this, three subsets containing 2 in one in the other one in the other one, like this. So all 4 objects will be partitioned into 3. So how many possibilities that you can do that? So n factorial, that is 4 factorial, and you divide by the number in each partition. Here there you have 2, here you have 1, here you have another one. So 2 factorial divided by 1 factorial and 1 factorial. So how many possibilities are there? 12 possibilities. Okay. What you have to do is figure out how many will be there in each subset and divide that by the factorial of the total number. Right? Okay. Try this one. In how many ways can 7 businessmen attending a convention or a conference, let's say, be assigned to 1 triple and 2 double hotel rooms? What does that mean? So you have 7 businessmen. You know, when you do bookings in the hotels, they have different types of rooms, right? So in this hotel, you have triple rooms. That means 3 can be accommodated, and double room where 2 can be accommodated, right? So there's 1 triple room, 2 double. So that means you divide it into 3 subsets. First one contains 1 triple. 3 can accommodate in that room, and 2 double rooms. So altogether, you have 7 members. A is 3. So how do you arrange them? So 1 factorial divided by 3 factorial, 2 factorial, 2 factorial. Right? So 210 different ways that you can arrange these 7 businessmen into these 3 bedrooms. 210. It's very big, right? That many different ways that you can arrange 7 people into these 3 rooms. Okay. Any questions up to now? Try this one. A group of 100 students are planning to go on a field trip. Right? So there are 4 vehicles and the number of seats are given as below. The vehicles are a bus, a minibus, and 2 vans. Right? The bus contains 52 seats, minibus contains 26 seats, one van contains 10 seats, the other van contains 12 seats. How many different ways are there to divide these 100 students into the 4 vehicles? Try this one. So you have 100 batchmates. Divide them into 4 vehicles. Bus can have 52. Minibus can accommodate 26 students. One van can contain 10 students. Other van can contain 12 students. So altogether there's 100, right? 52 plus 26 plus 10 plus 12, 100 seats. Now this you may not be able to do by hand. You will need a calculator, okay? If you have the answer, share it with me. I also don't have the answer. So you have to have 100 factorial divided by 52 factorial, 26 factorial, 10 factorial, 12 factorial. I also don't have the answer, so if you can find it, let me know. Anybody who has the answer? No one got the answer? It's going to be a huge number. You can use online calculators for that. This is what I got. Yeah. Right. So this is going to be a huge number, 10 to the 48, right? A very, very huge number. Okay. Now you know how to do that. So next time when you are planning a field trip, think about it. Right. The last example, we did this one, right? So here's something for you to think about, right? Kind of an exercise. So hope you can remember about the lottery draws that I mentioned. This is the setup of the Mahajana Sampata. If you actually watch the raffle draw, in Mahajana Sampata, they select one letter and 6 numbers. These 6 numbers, they select the first number out of a bin of going from 0 to 9, right? There will be ping pong balls containing 0 to 9. And the next container also, likewise, you'll have 6 containers. Each time you pick one randomly from these containers, right? So can you find out how many possible results are there for a draw of Mahajana Sampata? Okay. How many different results can be there, right? And you know only one is the winner, right? So if the lottery board is printing all possible results, how many tickets that they should print? I don't know whether they print all the tickets or whether they just print few of them, right? Anyway, you can figure out how many different results can be there for a Mahajana Sampata draw. Right now, there are different setups. If you think about Goviseta, it is a different one. I think they have 80 balls in a box, and out of them, they select a few balls. There you don't have repetitions. And then they select the zodiac sign and a letter. You know, likewise, there are other combinations also. So you can, there also you can actually calculate how many different results can be there, right, for a single draw, right? And one ticket is 20 rupees. So if they print all the tickets and if they sell all the tickets, what is the amount they are going to earn, right? The lottery board and the development lottery board and national lottery board. So you can think about it, right? So this is just for your fun, right? Try a few of the lottery draws available in Sri Lanka. There are many. Again, you can figure out how many possibilities are there to have the result. Okay. So with that, we finish first chapter, counting techniques, but we are coming back to them when we do probability. That is the second chapter. So try to do a few other examples. Try to find examples or exercise from textbooks or any introduction to probability textbook will contain this chapter, and even online tutorials are there. So try some questions by your own and try to figure out how to apply these theorems and the principles that you learned in the chapter.